Welcome back to Lucky Naresh Physics channel. Students, in this session I am going to discuss about refraction of light, cause of refraction of light, rules for refraction of light, laws of refraction and refractive index. Students, you might have observed that when we kept one pencil inside a tumbler which is filled with water, at the surface of separation you might have observed that it appears to bend here. Why it happens? Because due to refraction of light. What is meant by refraction of light? When light travels from one medium to another medium, it appears to bend at the surface of separation. This phenomena is called refraction of light. Here, the surface which separates two mediums is called surface of separation. Look at here. Here light is traveling from air to water. Okay. At the surface of separation, this pencil appears to bend here due to refraction of light. What is the cause of refraction of light? See, when light travels from one medium to another medium, there is a change in wavelength. Due to that, its speed changes. Because of that, refraction of light takes place. Look at here. See, we know that V equal to n lambda. That means V equal to frequency into wavelength. Speed of light is equal to frequency into wavelength of the light. Here, frequency constant. So from this what we can write? V by lambda equal to constant. That implies V directly proportional to lambda. That means if lambda changes, V changes. So here, when light travels from one medium to another medium, its wavelength changes. Due to that, its speed changes. Because of that, bending takes place. That bending of light only we used to call refraction of light. Now rules for refraction of light. Rule 1. When light travels from rarer medium to denser medium, it bends towards the normal. Here, what is rarer medium and what is denser medium? The medium in which speed of light is more, that is rarer medium. The medium in which speed of light is less, that is denser medium. For example, when light is traveling from air to glass, it bends towards the normal. Here air is rarer medium, glass is denser medium, because the speed of light in air is more than compared to speed of light in glass. Next, rule 2. Rule 2. When light is traveling from denser medium to rarer medium, it bends away from the normal. For suppose, light is traveling from glass to air, it bends away from the normal. In the same way, you can take light is traveling from water to air, it bends away from the normal. That is rule 2. Next, rule 3. When light hits the surface perpendicularly, no refraction takes place. It will go straight. That's about rules for refraction of light. Next, we will discuss about laws of refraction. Now, laws of refraction of light. First law. Incident ray, refracted ray and normal at the point of incidence lie on the same plane. Look at here. Incident ray, refracted ray and normal at the point of incidence will lie on the same plane. Look at here. For suppose, I will draw one plane here, vertical plane. See, in this vertical plane, if you observe means incident ray, refracted ray and normal at the point of incidence lie on the same plane. That means all these three are lie on this vertical plane. What is Snell's law? The ratio of sine angle of incidence to the sine angle of refraction is constant. Is called Snell's law. Look at here. Ratio of sine angle of incidence to the sine angle of refraction is constant. The constant we represent with letter n or mu. Constant. The constant we represent with letter n or mu. Where this constant n or mu is called refractive index. Where n is called refractive index. Okay. So, what is refractive index here? Refractive index means every medium has its own refractive index. Refractive index express about bending of light. That means the bending of light is expressed in terms of refractive index. How? We will know about that. Okay. Now refractive index. The bending of light is expressed in terms of refractive index. For suppose, when light is traveling from one medium to another medium, if that another medium has more refractive index, then there will be more bending in that medium. If it has less refractive index, then there will be less bending in that medium. We have two types of refractive index. One is absolute refractive index and another one is relative refractive index. First we will discuss about absolute refractive index. Look at here. Absolute refractive index. It is the ratio of speed of light in air or vacuum to the speed of light in that given medium. That is n equal to c by v. Here, if you observe, absolute refractive index of air is 1. Absolute refractive index of glass is 1.5. And absolute refractive index of diamond is 2.42. In board exam, they will give one question. The refractive index of diamond is 2.42. What does it mean? Then you have to tell that the ratio of speed of light in air to the speed of light in diamond is 2.42. Next, relative refractive index. What is meant by relative refractive index? Look at here. See, relative refractive index means when light is traveling from one medium to another medium. For suppose it is traveling from one medium 1 to medium 2. Look at here. When light is traveling from medium 1 to medium 2. Okay. So we need to know refractive index of medium 2. Here, refractive index of medium 2 with respect to medium 1 is equal to refractive index of medium 2 by refractive index of medium 1. But here n2 means in terms of absolute refractive index, I will write c by v2 by n1 means in terms of absolute refractive index, I will write c by v1. So c and c cancel here. So what will you get? You will get v1 by v2. So n21 is equal to v1 by v2. That means refractive index of 2 with respect to 1 is equal to speed of light in medium 1 to the speed of light in medium 2. That's about relative refractive index. In next session, we will discuss about lens. Thanks for watching my video. Please subscribe and click the bell icon for all notifications. Thank you.